So it's my great pleasure to introduce you today, Professor Choi. So from the Hassan Medical Center, which is one of the main and biggest supporter of SOFA and of its consortium, working with SOFA and your team on simulating arthroscopy. Using SOFA for simulators for arthroscopic simulation and vascular intervention. So I'll let you then present here. You are now the presenter, and you will be able to pass the slides as you'd like. Thank you.
Okay, thank you, Dr. Hello, everyone. I'm Jaeson Choi from Hassan Medical Center. It is my great pleasure to be here and join this symposium. And actually, unlike the other previous great presentations, our work is very humble in initial experience, so please understand about that. Okay, and I'll try to make it very as simple as possible. Can you see the slides?
Yeah, we can see the slides passing. Yeah,
it takes some time. Yes. Okay, our team is we have a nickname as Heart Lab, which is healthcare automation and robotics technology lab, and we are a very small team in our hospital, and our main focus is to develop many types of medical robots, mostly for surgery and intervention application. We began our team in 2012, and fortunately, could have great opportunity to open another great facility, a small company named LN Robotics, which was opened last year, and we are going to pursue further commercialization or practicalization of our results. The first one is arthroscope surgery simulator. About 5 years ago, I was approached by a small Korean company which wanted to develop this simulator, and we started a small government-supported project. And our work for this simulator work was to implement the main code of the surgical motion simulation using simulation engine. The application was two orthopedic surgeries using arthroscope, the kind of endoscope for orthopedic surgery. And the first one was rotator cuff tear repair, which is to so basically it is to retract the torn parts of muscle to the other parts of bone to make the connection again. And another surgery application was Bankart lesion repair, which is basically in terms of the motion and simulator technology is very similar as the other one, and just the content is a little bit different. So in the beginning, we analyzed the surgery procedure itself from the video data provided by the surgeons, and we broke down the specific procedures into the small tasks. We had to identify the tools and specific tasks for the simulation. And then we identified the tools needed for the simulation and the functions for the tool for the simulation for the two types of surgeries. And then, just as usual process you do when you implement the simulation, we extracted data from the patient medical imaging data, and then we made it into 3D model, and then we put it onto SOFA as a form of SOFA compatible data format. And for this simulation, in addition to the default functions in the SOFA framework, we need to code short parts for the specific tasks implementation. And just I'd like to show you a few examples. And these two, I'd like to skip the video clip to make it short. These two are basically the online modification of the mesh structure to simulate the surface modification. And then, this is the mesh modification. And then in another task, we needed to kind of combine the motion. So combination of mesh modification and moving the hard and soft parts of the simulated contents. And in another scenario, we needed to implement this kind of consecutive motions tasks, which is composed of sub-tasks as shown here in the diagrams. So we needed to make a specific code as a plugin for SOPA to implement these sub-tasks to be combined for the whole task procedure, task simulation. Actually, I do have video clips in Vimeo, but I'll skip all the presentation for now. And another scenario was to implement usual moving and manipulation with the thread-like structures for knot tying and knot manipulation simulation. Okay, so now, so our work was to make the C++ code as a plugin format for SOPA engine, and then the company has utilized our code for implementation of their whole system, which is to include their custom haptic interface and the whole system as shown here. I'm not sure if they have moved on to the commercialization of this product, but anyway, after 4 years of project, the final stage was having this kind of prototype of their product. And then our next experience was about vascular intervention application. Actually, yeah, on my side, the slides comes a little bit late.
We can actually, at least I can see them immediately when you click. Maybe there is a bit of delay, but here I can see thorax with X-ray and surgeons
Yes.
operating.
Yeah. So as you may know, this is a general procedure of the cardiologists when they are doing the vascular intervention procedure. And we have been developing a kind of assist robot system for this cardiology intervention procedure to make it more efficient and precise. And during the development process, we have come up with the idea that we may try some kind of artificial. So now the development stages has been up to this clinical prototype. And then during this development, we come up with the idea that we may try the AI application in this for this system. One idea was to implement this automated control of the guide wire utilizing this RL algorithm, which is very well-known algorithm. So in the beginning, we started with Unity because it was more simpler for us to try, and we implemented this simple system experimental setup with Unity, and we checked the feasibility. And then, of course, we did in parallel a physical system configuration together. Actually, as I recall correctly, last year at the SOFA Symposium, one German research institution, maybe Fraunhofer, presented their work as very similar as this one, and our work is far more humbler one than theirs. But anyway, we tried both simulation, computer simulation based one, and physical phantom based simulation to implement or to see the feasibility of automatic control by reinforcement learning. And then certainly we looked at the SOPA because we wanted. We know Unity has very good advantages and many good merits, but still, for more realistic simulation, SOPA would be the better answer, we thought, and so we tried using SOPA for this similar configuration. And then through very general process of simulation setup, and with the kind help of SOPA community, we could be fortunate enough to utilize this SOPA beam adapter module so that we can have very easily implement our work. And by simply setting some parameters in the beam adapter module, we can very easily implement our work. And the system structure is very simple. Just we used two separate computers connected by TCP socket. One is for the AI engine, the other is for SOPA simulator engine. And through general process of our algorithm implementation, setting with the actions and states and definitions of rewards, and then actually initially the result was not so good because just our understanding was not good enough, and after refining the parameters and settings, we could improve. And actually, one big leap was by this reward shaping. We didn't have much enough information about this our algorithm, and we found data, this technique, and we applied this reward shaping, and then we could begin to see some kind of acceptable result, as shown here. So now, maybe this time I need to share the video.
And while you are actually preparing the video, do not hesitate to already type your questions. If you have some questions for Professor Choi, if you have a mic, you can already prepare and unmute yourself and get ready for questions. Yeah, perfect. We see that perfectly.
Yeah. And this is very simple result. So you can see the beam adapter model finds the way by itself to the any given target. So, and then maybe my last slide can be replaced by this another video. Sure.
Is there any question? Yeah, see François already asking. Yeah, that's really cool. I have some questions, but I'll let. Yeah, perfect. For arthroscopic simulation, Fabien from Switzerland. I think you're still in Switzerland, right, Fabien? Is asking for. Is asking more or less. Okay, so he's asking for are haptic forces. In the arthroscopic simulation. Are haptic forces meant to be realistic? So have you measured, the forces returned by the simulation and compare them to what has been measured in the reality?
Yeah, there are some level of different levels of force we need to feedback, but actually, anyway. Generally, the force feedback by current haptic interface hardwares, and I'm sorry, but even with SOPA engine, still the surgeon's response is not so happy about the fidelity. So I think, and also there are some papers claiming that the force feedback is not kind of crucial component for the successful simulation for surgical training simulator. So we can do it, but we don't need that very high fidelity.
And is there several levels of retractation of the tendon testing mode? That was the second question of Fabien.
I think I should say there was only single level. I'm not sure that the meaning about the meaning of this.
What do you mean, Fabien? Can you if you can specify a bit more about, at least I don't know personally what it means, the level of retractation. Is that some kind of strategy to access the tendon, or different kind of location? If there is any other question, do not hesitate. And while
while I'm waiting for the question.
So depending on the degree of severity of the rupture, the muscle can be harder to pull back for reattaching it. So it would be to model different kind of stiffness, I guess.
Mr. or Miss Fabian Pian is right, correct. But our implementation was not that good enough to implement this level of simulation.
Yeah, would be definitely happy to see more and to help more, even you in the future for the future and the next steps of your simulations. I think there is also in your presentation a lot of connections with what we saw before. For instance, the machine learning approaches or reinforcement learning platform that Pierre presented just before. I think it's very connected to what you're doing also on learning on your side. And later on this afternoon, there would be also, I saw that you were interested in endovascular navigation, and especially I saw some stent deployment. There would be a presentation of a simulation where a stent deploys. That's a presentation that will be done by Camille later on this afternoon. So thank you again for taking the time. So yeah, I see Camille typing. Maybe is there a question, or I'll let you type. And okay, yeah, sounds very related. So Camille, again, if you'd like to get if you'd like to get connected or know more about what is done at the Assad Medical Center, do not hesitate to get in touch. And I was thinking as well, the work of Pierre I mentioned, and the work also at Fraunhofer. As you said, I think it's in Germany, the research center in Germany, Fraunhofer. It's very close to what they are also looking at with SOFA. So yeah, anytime later on could be interesting to gather, and maybe for having a common framework. I mean, a common project together.